So today we're going to focus on HAULNET. Now, HAULNET is part of the TALPAC family, and it's what we consider the beginning of the next generation in haulage simulation software products. Just a quick agenda for today. We're going to look at why use HAULNET. We'll go through the HAULNET haulage data, network data required. We'll look at our equipment database, which is something fairly new for all of you. We'll look at the 3D visualization aspects of HAULNET. We'll look at whole root analysis, which is really the key of HAULNET as a software product. And then Stu Mills will give you a demonstration towards the end. So most of you would have used TALPAC or seen TALPAC in your careers. It's a productivity simulation suite of products. Obviously, you're looking at trucking and haulage simulation. It works in conjunction with your production planning tools to validate schedules, and of course in our case that's XPAC and Exact. But of course you can use it with any other planning software products out on the market. And the reason you're doing this is to make sure your production forecasts are reliable and you can plan for things like travel times and truck hours and choosing the right kind of fleets. So why use HAULNET? Historically, over the last sort of 10 to 20 years, there's been the mining industry has been in a phase of rapid growth and expansion, and we've seen that with the major iron ore players, especially BHP and Rio Tinto, bringing on new mines, forking out billions of dollars in expansion plans. But of recent times, what we're seeing is a growing trend towards a huge focus on productivity and reducing costs. And trucking and haulage is one of mining's biggest costs, especially in large operations. And it can often be marginal. So, that being the case, a product like HAULNET is coming right into focus for a lot of our clients. And the ability to accurately forecast these trucking movements and material movements and trucking requirements with confidence is really key, especially when you're doing studies and looking at the types of truck and loader fleets you're wanting to bring onto your operations. So the business case for HAULNET is really simple. It allows you to quickly determine the fastest or shortest route from an infinite number of possible combinations. So when you're running schedule scenarios and you're looking at the blocks of ore in your pit and possible destinations, dumps, plants, stockpiles, etc., you want to know with confidence that you're sending each block of ore or waste to the correct location with the most efficiency. And by able to do that, you're maximising your production and also you're maximising your operating margins. So some of the key aspects of HAULNET, what it allows you to do is very accurately calculate the optimal haul route, like I mentioned, from every source in the pit to every possible destination throughout an entire schedule. So that can be done right down to the daily and weekly and even the shift level, right out to the life of mine planning horizon. It allows you to accurately calculate your travel times and truck hours associated with those haul routes and the different types of fleets and loaders. And most importantly these days, it allows you to calculate fuel consumption. And what we're hearing from almost all of our clients is that's a very, very topical aspect at the moment, especially in operations where fuel prices are increasing and productivity needs to increase as well. You look at truck productivity in tonnes per hour, and another valuable aspect is you can evaluate alternative trucks and fleets on your mine. So the HAULNET design philosophy was very simple from the start. It needed to be a robust yet simple design. It had to be extremely easy to use, obviously, because the more complicated a product is, the less usage or uptake we tend to see. It uses a process-driven user interface. Now this is going to become a common theme throughout RPM's software offerings over the next 12 months, and you'll see that and hear about it much more often. And what that allows us to do is it reduces the training time and it reduces the amount of time taken to get up to speed with our product. HAULNET had to produce auditable and repeatable results, and this was key. Obviously, to be able to trust the process, you need to be able to repeat the results, especially throughout your planning cycles. It offers an extremely fast analysis process, and like I mentioned before, you can literally do an infinite number of calculations over a schedule to achieve the desired outcome. And it's able to interface with external software products. So obviously in our case we prefer XPAC and Exact, but HAULNET has the ability to talk through a comm interface to programs as simple as Excel. and it's a standalone product if need be. So some of the key features of HAULNET, again, as I mentioned, it combines easily with your design and scheduling packages. So in our case with XPAC, we utilise HAULNET very, very often in validating or calculating travel times and truck hours through the entire schedule that XPAC produces, and bringing that into the schedule for productivity and costing analysis. It offers 3D visualization of your entire haulage network, which is a very, very great feature. Obviously, you can visualize where the trucks are heading and to which parts of the mine. And it's flexible and a very straightforward configuration, so it takes minimal effort to set up. So the haulage network data that's required, 5 haul objects are supported, and these come directly from your design packages. So road strings, sources, destinations, annotations, and of course directional arcs. And of course these can all be customized to include any required data fields. So depending on how your schedule is set up or how you want to analyze your data, you can name it via pit, pushback, road type, or any other data field you wish to include. And it supports multi-value classification data fields as well. The equipment database, this is something that's been really key to RPM software development in recent times. Historically, TALPAC had an equipment database embedded in it, and what we've done is pull out the TALPAC database and create an RPM database that's central to all our products. So HAULNET utilises this TALPAC equipment database, and of course that includes OEM data, and you can also you can customise the trucking and loader data in that for your own specific site. As I mentioned before, it allows calculation of fuel burn, and your load and dump times are user configurable. So if you've got different specifications for each of your loaders and each of your trucks or truck fleets, you can customise the database to suit. It allows for site-specific calibration of your model, and it reads its final truck speed from the equipment database as well. And there's just a quick screenshot of the equipment database as it exists today. So down the left-hand side, you can see the brands of equipment, and we've clicked on Caterpillar at the moment, and then you can see all the different types of trucks, right from 785s down to 797s, and all the properties that are associated with that. 3D visualization. So this is a really nice aspect of HAULNET. It allows some very good 3D visualization of the entire mine. Again, it's completely user configurable, so you can make the arcs, the sources, destinations, and nodes look any which way you'd like. You can import feature layers to create a true 3D scene. So this is just an import feature layer from your design package. So it can come in as either a DXF or at the moment a Vulkan 00T file. You've got many visualization options. You can rotate the view, you can zoom, you can pan, you can clip different parts of the pit if you're focusing on different areas, and also you can filter by any single property of an object or any combination of properties and objects in the model. And also the legends are created for any property of an object as well. So haul route analysis, and this is really the crux of HAULNET. It allows for 4 haul route analysis types. So you can look at the route between 2 points, you can look at the nearest sources, the nearest destinations, and the nearest annotations from any source in the model. There's 2 hauling objectives, so you can either choose the quickest route or the shortest route, depending on the objective of your schedule. And you can even look at directional hauling and loading options. So you can look at single direction haul roads, you can look at bi-directional, so you can have a loaded truck going out of the pit and empty one coming back, and it will source the most efficient route for that truck. You can select start and end locations, and you can select different trucks from the equipment database, which is really key. And this is how you do the analysis of different trucks and fleets throughout a schedule. You can run data on, say, a 785 Caterpillar versus a 797 and look at productivity. And then once you've done that analysis, every haul route in the HAULNET model can be exported to TALPAC for further Monte Carlo simulation and other detailed costing aspects. So what I'll do now is I'll pass on to Stu Mills for an in-depth live demonstration. So I hope you enjoy it.
Welcome Hello everybody and welcome to this demonstration of HAULNET. There's 4 key areas we'll look at through the demonstration. One will be to have an overview of a whole network model, and we're going to look at an open pit model as well as an underground model. We'll look at some possible use cases for a whole network model and how it can be used. And then we'll look at some more of the features in detail, including the equipment database. And finally we'll look at the workflow process methodology that's been set up to allow you to create and use the model. Okay, so we're looking at an open pit whole network model here. It's comprised of an open pit split into 4 pushbacks. We've got 2 waste dumps that are shown in blue in this case, and a dump leach pad, and we can see our processing plant down in this bottom left hand corner. The scene at the moment has had a filter applied to it, so that we are only seeing the relevant information for pushback 5, and these filters are all user configurable, and we'll have a look at those a little bit later. The scene has a legend applied to allow the roads to be coloured according to your requirements. In this case we can see our pit ramps are in purple, our surface roads are in a light grey, and our dump ramps are in a red colour. So as I say, it just provides some contextual information. And finally we've got our feature layers to provide that final bit of location information to put everything in context of what we're looking at. We've got several feature layers here, one for our surface and final pit shell design, a couple for our dumps and our dump leach pads and our processing plant. They've all been imported from .dot files from Vulkan, and they're just straight in. So that's what an open pit model looks like. If we now just swap over to our underground model, and as I say, this model is set up specifically for underground. We can see we've got our surface location, surface processing plant. We've got our major decline coming down with spiral declines at both ends of the ore body. We've got our hoisting and ventilation shafts. We've got our feature layers in here once again for our surface layout. Our red colour is our ore body, and you can see that the ore body feature layer has been made transparent, so you can actually see through the feature layer and see what's inside. So here we've had these blue vertical lines here are our ore passes and tip points just here. We can then move on to these extraction drives here, where we can see our stopes have been shown here. So that's the 400 level, and that's an individual stope, all imported as sources into the model. So if we have a look at a quick analysis while we're here, we'll do an analysis between 2 known points. We'll find the quickest path, we'll do a full cycle analysis, and we've got an option here to select a source from a drop-down box, or to select it graphically from the screen. So we've selected that. Now select the end location, and we'll put it up to the top, to the tip point there, ore pass number 1. You can select a truck type. If you want to do a quickest path, you need to select a relevant truck type to use. And we go find the route. That's returned the analysis down the bottom here. And by clicking on the results table, it'll highlight the route you've selected that has been selected through the network between those 2 points. You can see that it's 14 minutes forward travel time and a reverse travel time of 11 minutes. So that's all I really want to cover on the open pit model at the moment. We'll have a look at some of the more detailed information later on as we go through the open pit model. We talked about use cases. The first use case is using whole network as all by itself as a standalone application. We've just seen how we can calculate a route through a network, any combination. Another way of using whole network is through the COM interface. And we've got an example here of a spreadsheet that is using the COM interface, and with a small macro in the background we've entered in here the manual data, our source and our destination and what truck we'd like to use. By hitting this button up here we have a small macro that now returns our travel time through the network between any of these locations. So you can see there's 14 haul routes have just been analysed, giving us our travel time and our fuel consumption for each of those specific routes. So if you're working with spreadsheets, you want information out, it's quite easy to set up the spreadsheet to return that information for you. Using COM interface, we can also have scripted options within XPack or Exact to extract the data out of a whole network model and populate your database fields with travel times and distances between known locations. That's in use in quite a few of our clients' models at the moment. And the third option here is what RPM's been working on, what we're calling our Openpit metals scheduling solution. This is a fully integrated solution that provides the integration of an XPack model with a whole network model. You can see this is a scene directly out of the scheduling model, scheduling solution. We can see our whole network roads, our ramps, and down here we can see we've got our bench blocks, and we're on bench 780 here, and the red blocks here are what we're calling our toe blocks. That's where the ramp has gone through that bench. There's been a connection made to the nearest source, and we've coloured it red so we can validate and check that everything is legitimate in the model. So this is an example of what a fully integrated model will look like. You've got the full capabilities of both your scheduling engine and your whole network model fully combined together. Okay, we'll just move back now to our whole network model. Just a quick overview here. The scene here is made up of different panels down the left, in the center, down the right, and on the bottom. This can be configured in any combination you would like. The 3D scene, for example, this tab can be relocated onto a second screen if you're using two screens, which gives you maximum graphical capability, and it allows more flexibility. Your help documentation is available. Once again, it's dockable. It can be moved onto to a second screen, so you can have access to it while you're operating your model. So, properties of a whole network. Let's have a quick look here. We've got some whole ramp strings here. If we select a whole ramp and click on our Properties tab, for this arc that we've highlighted, we can see the compulsory fields that have been populated, the description, we know the length and the grade of that field, of that arc. We also know its rolling resistance and traction coefficient. These two values are required for further downstream travel time calculations. And below that we have what we call our custom fields. These are user definable to suit any client's models. And below we have some directional data, which we'll talk about later. If you want to change any of the data, we can just change it directly here on the screen for a single arc. We can also then select multiple arcs to change the data on. So it's all user accessible. Down in the bottom here we have we have a box for it, a tick box called Enabled. This allows you to turn off a section of road if you want to. If you want to test out a scenario, if a ramp is not available at some point in time, you can disable that ramp and then to calculate an alternative haul route out of your pit. Okay, if we just now look at we've looked at our properties. This is where we set our properties up. We have for an arc, we have our system fields, which are height down to creation type, rolling resistance, traction coefficient, and these are at the bottom here are our custom fields. These are all user definable and can be added to. They can be classification fields, numeric fields. They can also be text fields. So it's all user definable. It allows the client to build up whatever combination he would like. Moving across onto our trucks section here, as Luke was saying, we now have our equipment database. By clicking the add button, you get access to the full database here. You can select any sort of truck you like, Komatsu, rear dump trucks. As I say, the equipment database you see within TALPAC is now fully exposed within Haul Network. Okay, filters. We have a tab down here for filters. Mentioned earlier that this scene had been filtered to the highlighted filter here, pushback 5. We can see we've got several other filters on here. It's easy enough to select them and have different views of what you want to look at. If you just want to look at the pit ramps, it's all by themselves. And we'll go back to that one. Up here we can add, delete, copy and edit. So if we have a look at the current filter we've got on, you can see we've got ability to name it, to apply user sliders to limit the X, Y and Z area it covers, and then we can control the arcs that we see through a set of expressions and also the annotations. It's a very flexible system and provides maximum usability. Okay, the final thing we need to look at now, we're going to look at was the workflow process. So far in the presentation we've been reviewing an established Haul Network model. If we look at the workflow process now and how it guides the users through the establishment of a Haul Network model so it's ready to be analysed and interrogated. So the 4 processes, 1 is import, 2 is interpret, 3 is rationalize, and 4 is analyze. So 3 preparation processes and 1 analysis process. To import our objects, we can import any of the 5 objects here, arcs, sources, destination and roads, and directional arcs. It's a straightforward process. We'll look at a road string here. It provides a preview of your file you're importing. And you can see we've got our compulsory fields here of X, Y, Z and string ID, some compulsory fields and some optional fields. So we go next. The file has been mapped to the fields in the database, and then this will directly import into your model. Okay, so once we've imported the data, we need to interpret the data. Interpretation simplifies the mine planning process because it can create a valid haulage network from any number of design strings. These design strings may have come from a number of site design engineers, and they've been combined together you need to combine them together to create a single haulage network to allow you to do your calculations. Haul Network uses defined tolerances to create node-to-node connections, and node-to-arc and arc-to-arc connections. Once the data has been interpreted and these connections have been joined together, you can have a completed continuous haulage network that you can then analyze. This is before whole network. This is a task that will take quite some time. In this example, we've got 900 arcs, and there was 55 interpretation actions performed on this data set, just to connect up where our design work wasn't exactly right, and nodes weren't snapped together. In another example, we had a client with a model that's got 26,000 arcs, and there was close to 6,000 interpretation actions performed. So to do that manually and identify each of those interpretation actions manually would take quite some time. Thereby cleaning up any issues with designs and lines, it solves a lot of problems. The other thing it does in the interpretation phase is connects any of our annotations. It creates an association with any annotation to the network, so that then forms part of the network. Okay, once we've analysed, we've interpreted, we can move on to Rationalize. Rationalize is a process to simplify the whole network without affecting the integrity of the network. Commonly, road centerlines are derived by draping centerlines design strings over a surface DTM, and this may have been derived from satellite data. So you get a lot of redundant points that do not make any difference to the travel time calculations. So having large amounts of non-essential waypoints is common, and this is a way of cleaning those up and remove any unnecessary non-essential waypoints. So once we've imported, interpreted, and rationalized our data, we're ready to analyze it. So as Luke mentioned earlier, we've got 4 methods. We can analyze between 2 known points. We can find the nearest sources to a known point. We can find the nearest destinations or the nearest annotations. We can find the shortest or quickest path. We can report a full cycle. We can select, we'll just select a couple of points here. We can select a start point, and we'll select the crusher as the destination. We can select a truck that we want to use to analyze, and we can find the route between those 2 points. Once again, in the result table, it gives us our results, gives us our time, gives us our travel time and fuel consumed for the route. Selecting the route also in the results table also highlights where the route is. We can now export this data directly to TALPAC. It's an option here, right click on the bottom and export to TALPAC. This prepares a file that you can import directly into TALPAC for further detailed Monte Carlo simulation in TALPAC. Speed limits. When we first start with a whole network, first setting up, you'll see that our speed limit here has been controlled by what the maximum speed of the truck that we're using. The sites will generally have their own traffic controls and speed limits, and it's quite often necessary to modify that, and that's easily achievable either by manually selecting whole routes, arcs, and modifying the speed here on this panel, or by using your filters to filter out what you want to see. For example, if you want to just see if you have a maximum speed limit in the pit, you can just filter it for your pit ramps. You can highlight your pit ramps completely and then apply a speed limit to those that's necessary. Filters, we'll go back to that filter here. We have the ability to simulate stop signs and other traffic controls that you may have in your network. We have what we call directional arcs. Directional arcs allow you to set speed limits on both directions of any arc. On this arc here we can see we can set a speed limit going to the east and one to the west. So if we're heading down the pit and we need to put a stop sign there on in our network, we can nominate that arc there to have a 0 final maximum speed. That will mean that the truck will need to stop before proceeding down that ramp. The other, just swapping back to the underground model at the moment, just a final view, we can see analysis is all the same here as well. We looked at that before, and in completing incomplete haul networks, we have a functionality here to allow you to create manual arcs and complete haul routes that may not quite be complete. Okay, so just summarising then, we've had a look at the overall haul network models. We've looked at possible use cases for a haul network model. Some of the features, we didn't cover all our features. It's far too many, need to cover them all today. But we did have a look at the equipment database. We looked at the primary process flow on how we would set up a model. So I'd like to pass back to Luke now to summarise.
Thanks, Stu. That was a fantastic presentation. So look, guys, just to summarise and wrap up before we take some questions. Look, the reason HAULNET is so relevant to today's market is that it really does help maximise productivity and minimise your haulage costs throughout your planning cycle, right from your life of mine planning horizon down to your short-term plans. It allows you to assess really an infinite number of possible route combinations from any source to any destination throughout an entire schedule. It's very robust and, as you saw then, was extremely simple to use and to set up. And what it does, it just gives you real confidence in your production forecast for your trucking fleets. So what we'll do now, I'll hand back to Nicole, and we're happy to take some questions for the next few minutes. If you do miss out on getting some questions in right now, please feel free to contact either Stuart or I, or get directly in contact with info at RPMGlobal following the discussion today. So I'll hand back to Nicole, and thank you very much for your time.
Okay, great. Thanks, guys. We don't have any questions that have come through yet. If you guys do have questions, please use there's a little raise your hand icon that you can use, and we can unmute your phone lines. Alternatively, please do pop them in the questions section, and we can address them from there. So I'm not sure if there are any questions that have come through at this stage. Give everyone just a couple of seconds. As Luke said, though, if you do have any questions after the session, please get in touch with us. What we'll also do as well is send out a feedback survey to everyone that has come along today, because we would love to get your feedback. And all of your feedback will go towards improving our webinar series as we move forward. And we are looking to run these webinars more and more often. So, okay, we do have a question here. I'm not sure who's the best one to answer this one, but is there a way to model multiple loader systems sharing haul roads?
No, not at the moment. The haul network package will model truck usage on a network and travel times between points. It doesn't handle haulage combinations, loading combinations. We need to go back to TALPAC and do your truck and loader analysis there. Thank you.
Just to add to that quickly, what we are doing as a consulting project is some simulation where we do take that into account, but that's not actually a software offering at this point. We can offer that as a consulting service, and we can set up those simulations very, very quickly. So if that's something that you're interested in, definitely feel free to contact us, and we can go through that in more detail.
Okay, well what we might do, if there's no more questions, we might just wrap it up for today. Thank you again to everyone for attending our session. We do hope that you found it valuable, and as I said, we would love to get your feedback when we send out our short feedback survey shortly after the session. If you'd like to get into contact with Luke or Stuart, or if you'd like to arrange a more detailed demonstration of HAULNET, just send us an email at info@rpmglobal.com. Otherwise, thank you again and enjoy the rest of your day.